In modern combat, survival can be decided in a single second, when the threat is already in the air, and the shield must respond before the impact exists.
Active protection systems create an invisible dome, watching every angle, every second, for the signature of an incoming strike. Most anti-armor threats arrive fast, low, and from unexpected cover, using terrain as the first layer of concealment. APS begins with detection, finding a threat early enough to create time where none exists. Radar gives the system distance, direction, and speed, turning empty air into measurable data. Cameras and infrared sensors help confirm what radar detects, reducing false alarms in complex terrain. Sensor fusion turns multiple imperfect views into one reliable picture, so the vehicle can decide without hesitation.
Once a threat is recognized, the real enemy is time, measured in fractions of a second.
The system classifies what's incoming, because different threats demand different responses.
APS defenses fall into two families: soft kill to confuse guidance, and hard kill to physically stop the threat.
Soft kill aims to deny the missile a clean view, disrupting the chain between seeker and target. Obscurants create a moving wall, forcing guided threats to guess, hesitate, or miss. Some soft kill methods attempt to degrade a seeker's guidance, forcing it to lose confidence in what it thinks it sees.
But if the threat keeps coming, soft kill becomes a delay, not a guarantee.
Hard kill is the last line, an automated intercept designed to neutralize the projectile before it hits armor.
The system chooses an intercept point where it can work, and where it minimizes risk to nearby forces.
Onboard computers must calculate trajectories instantly, without cloud help, without delay, under shock and dust.
Tracking is continuous, because the system must follow reality, not assumptions. Modern threats come from any angle, so protection must be all around, not just forward-facing. APS doesn't just fire, it decides, using safety logic designed to prevent dangerous engagements.
Protection must consider the people around the vehicle, because the battlefield is rarely empty.
At a critical threshold, the system commits, because waiting any longer means losing the chance. Hard kill neutralizes the threat in the air, turning a direct hit into a disrupted, harmless outcome.
The result is often subtle, because the best defense leaves no dramatic impact to film.
Intercept distance is chosen to reduce risk, balancing protection and safety in crowded environments.
Modern combat can deliver more than one threat, forcing the system to prioritize and respond in sequence.
The system focuses on what will hit first, because defending everything at once is rarely possible. APS is powerful, but not magical. Terrain, structures, and geometry still shape what sensors can see. Cities flood sensors with clutter, metal, glass, corners, demanding smarter filtering and confirmation. Avoiding false engagements is essential, because the defense must be trusted, not feared. APS is validated through rigorous testing, because milliseconds cannot be guessed. Some threats attack from above, targeting thinner armor, forcing APS to watch not just the horizon, but the sky. Higher sensor placement improves detection, especially for threats that arrive steeply. Hard kill responses are controlled, designed to focus effects toward the threat while limiting collateral risk. APS works best as one layer in a larger survival system: mobility, awareness, armor, and tactics. The timeline is brutal: detect, classify, decide, respond, before the target is even aware.
In training, you see the physics: an incoming strike interrupted before it becomes damage.
After engagement, systems must reset, returning to watchfulness immediately. High-speed computing and sensors demand power, and heat management becomes part of survivability.
APS isn't just armor, it's a defensive brain. It senses the threat, predicts the outcome, and acts before impact becomes inevitable.
Real environments are messy, wind, dust, rain, so detection must remain reliable in imperfect conditions.
APS must isolate a real danger inside a noisy world. Fast, precise, and repeatable.
Engagement decisions depend on confidence, because mistakes are dangerous, even in defense.
APS is automated, but crews still train to understand it, so the machine and humans stay aligned.
Safety sectors reduce risk, restricting defensive actions when bystanders or friendly troops are too close.
APS must work while the vehicle moves, because stopping to survive is not an option.
Stabilization keeps sensors locked, maintaining track quality when the platform is in motion.
The hardest test is dynamic, detecting and responding while everything is moving. Defensive systems must manage their countermeasures, because protection is finite during sustained contact. After engagements, vehicles must be restored to full readiness, fast, safe, and repeatable. Alerts give crews awareness so they can maneuver, communicate, and avoid exposure after an engagement. APS is timing, choosing the moment that maximizes success and minimizes risk. Many guided threats rely on a clean picture, and if that picture breaks, guidance can fail. Speed compresses options, forcing the defense to operate on the edge of physics. Close-range threats are the hardest because the system has less time to confirm and respond.
When time is short, confirmation must be fast and reliable, built on strong sensing and smart fusion.
Sometimes the safest action is restraint, because defense must protect the team, not endanger it.
APS changes tactics. Units move and position differently when the vehicle can defeat certain threats on its own.
Even small details matter. Dirty sensors can reduce detection quality at the worst moment. APS performance depends on software, validated through testing, refined through data, and guarded against errors.
Every engagement becomes data, used to improve detection, timing, and safety margins.
There are limits, obstructions, saturation, complex angles, so APS is a powerful tool, not invulnerability.
The best defense remains layered. Positioning, concealment, and protective systems working together.
APS buys time, often just enough to move, break line of sight, and change the geometry of the fight. Day or night, APS relies on sensors that can see beyond human perception. Infrared can reveal changes invisible to daylight, supporting detection when the battlefield goes dark.
Rain and moisture test sensor reliability, demanding robust design and careful calibration.
APS must keep functioning under stress, shock, vibration, and a hostile electromagnetic environment.
Defensive claims must be proven again and again, because lives will depend on consistency. Simulations stress the logic with thousands of scenarios, so real-world trials can validate what matters most. Many systems layer responses, attempting non-destructive measures first, then committing to intercept if needed. Standoff helps reduce impact energy reaching the vehicle, turning a direct strike into dispersed effects. A defense system is only valuable if crews trust it, because confidence shapes decisions under fire. As APS spreads globally, designs converge, driven by the same physics and the same threats. Threats evolve in speed and approach, pushing defensive systems to improve coverage and decision speed.
Better sensors, faster processing, smarter logic. APS is an arms race measured in milliseconds.
APS helps vehicles stay in the fight longer, but combined arms and smart movement remain essential.
The best defensive moment is the one that leaves nothing behind. No crater on the hull, no shattered armor, only continuation.
First, detect. Find the threat early enough to create a possible defense. Second, track. Follow the real path in real time, through clutter and movement. Third, decide. Use logic and safety rules to commit only when it's necessary and responsible. Fourth, respond. Soft kill to disrupt, hard kill to intercept, all within a breath of time.
APS buys survivability and freedom of movement, extra seconds to maneuver, coordinate, and endure.
The future is smarter shields, faster sensing, better classification, and safer engagements in crowded battle spaces. As guided threats spread, protection must become proactive, because armor alone can't outrun modern precision.
Sometimes victory looks like nothing at all, because the strike never reached its target.
Active protection systems defeat incoming missiles by doing what humans can't: seeing faster, thinking faster,